Hi everyone, so today we're going to be going over 5.6, which is using trigonometry to calculate angle size. So the main key point of today's lesson is using inverse operations. Now, usually when we solve equations, when we need to get x by itself, we need to move all the other numbers to one side, which is the same when we're using sine, cos, and tan. So when we're finding an angle, we need to get theta by itself. And in order to do that, we need to move sine, cos, or tan to the other side. When we do move it to the other side, we put the sine, cos, or tan with this little -1 up here. And this tells us that we're taking the inverse of sine, cos, or tan. So coming down to our first example here, we need to find the size of the angle correct to the nearest degree. So we're just working with degrees here, no minutes or seconds. So looking at A, we have this triangle here. My 5 is the hypotenuse, and I know because it's opposite the right angle. Now, in terms of this theta here, the 3.5 is opposite. So because I've got opposite and hypotenuse, I'm going to be using sine. So sine theta is equal to opposite over hypotenuse. I'm going to substitute in my values. So sine of theta is equal to 3.5 over 5. Now here is the point where I need theta by itself. So I'm going to take the inverse of sine to the other side. So I'm going to write theta is equal to the inverse sine. So sine with a little -1. And then in the bracket writing my 3.5 over 5. So coming over to my calculator now, I'm going to type in sine of -1, and the inverses you'll notice are right beneath our normal functions. So sine of -1, and then I'm going to type in 3.5 over 5, and that gives me that theta is equal to 44 degrees. I'm going to the nearest degree, so I don't have any decimal places. So doing the same thing with B, I've got my theta here, which means that my 5 is opposite and the 11 is adjacent. So because I've got opposite and adjacent, I'm using tan. So tan theta is equal to opposite over adjacent. Substituting in my values, I've got 5 over 11. And then getting theta by itself, I'm moving tan to the other side, so I'm taking the inverse tan, so tan -1 and 5 over 11. Coming over to my calculator, I'm typing in tan -1 and then putting in my fraction of 5 over 11. And I've got 24 degrees. So theta is equal to 24 degrees. Please, when you're giving me the answer, remember to put the degrees in there. Okay, so example 2, we need to find the size of the angle theta. Part A is correct to the nearest second and B is correct to the nearest minute. So looking at our angle here, 3.1 is adjacent and 7.2 is opposite. So I've got my tan angle here. So tan of theta is equal to opposite over adjacent. So 7.2 over 3.1. So theta is going to be equal to tan -1 of 7.2 over 3.1. So for part A, I'm coming over to my calculator. So tan -1, and then I'm typing in 7.2 and 3.1. Now I want this in degrees, minutes, and seconds. So I'm clicking on the little book. I'm picking 2 DMS, 2 degrees, minutes, and seconds, and pressing enter. So it's given me 66 degrees, 42 minutes, and 19.57 seconds. So part A, nearest to the correct to the nearest second, I'm going to have 66 degrees, 42 minutes, and 20 seconds, because I'm rounding up because of the 0.5. Then with part B, I'm going to have 66 degrees, and I'm staying at 42 minutes because this number is below 30, which means that I'm staying at 42 minutes, because remembering I've got 60 seconds in 1 minute, so for me to round up, this would need to be above 30, but because it's below 30, I'm staying at 42 minutes.